During this lecture session on quality by experimental design, the topic I am going to discuss that is basic principles of experimental design and experimental design methods. Now, while you carry out an experiment for product development purpose during offline quality control stage, certain principles you have to follow. Okay, so this is a technique, this is a tool you use, and as you are aware that any tool you propose or any tool you are going to use, certain basic principles you have to follow. So, related to experimental design, what are those basic principles? So, I am going to identify first those principles. I am going to discuss those principles first before I discuss the experimental design methods. So, while planning an experiment, during the planning stage, okay, you need to identify the response variables, you need to identify the input variables and the parameters, as well as you also must be aware of that what are the uncontrollable noise factors you may consider in experimentation. So, all these the details you must document during the planning stage of an experiment. Now, during this planning, the stage, it is to be ensured that the features of experimentation as stated, already we have mentioned that what are the features of an experimentations, like the simplicity, like the degree of the belief. Okay, so many other features we have considered in fact in the previous lecture session. Now, make sure that all these features are included in experimentation. Now, for inclusion of all these features, a number of approaches may be used. What are these approaches? First one is you must have an experimental plan. What is an experimental plan? The arrangement of factor levels and experimental units in the design. Is it okay? Experimental design means the combination of say the input factors. Okay, one set of say the input factors is essentially an experimental unit, and while we consider one experimental unit related to a particular factor, you select one particular level. So, against a particular say the factor, how many levels you should consider. So, this is basically coming under experimental plan. So, all these details first you work out. Then what is the grouping methods? I have already mentioned that what is a block. So, blocking of experimental units, that means suppose you want to carry out the experiments under different conditions. So, the set of experimental units in a particular condition, is it okay, may be referred to as one block. Is it okay? So, there could be in a particular experiment you can have one block, or there could be multiple say the blocks. So, this is referred to as the blocking principle. Randomization, the objective assignment of combinations of factor levels to experimental units. That means suppose you select all those combinations, that means the experimental units. Suppose there are 8 such experimental units. Now, you do experiment with one experimental unit. Now, out of 8, how do you select a particular say experimental unit? Okay. So, this selection should be based on the random assignment. Is it okay? So, the principle of randomization you have to follow. What is replication? The replication means repetition of experiments. That means the same experimental unit. Okay, you carry out an experiment, and not only once but the several times. okay, at a particular experimental unit for each experimental unit. So this is basically, there are the certain conditions actually, the effect of whether the variability which you get is due to some random causes or due to some assignable causes. So you must have clear idea. If you find that this is due to some random causes, that means the selection of the factors is considered to be appropriate. But if you find that when you go for replication, that means there will be the differences in the output response variable, okay, their values, and if these differences are due to is significant, and obviously maybe you have missed certain very important input variables. So this sort of the in-depth understanding of the system or the understanding of the design you will have by applying the replication principles. So what are these the 4 principles we have: experimental plan, grouping methods, randomizations, and replication. That means repetition of experiments, experimental units, or the measurements. Like if you refer to say reproducibility, repeatability in measurement systems, the error or the while you determine the measurement system's capability. Is it okay? So the repetition of experimentation is there. So the treatment combinations and the other components as part of the planned experiment. So sometimes this experimental unit is one experimental unit is referred to as the one treatment combination. So what is experimental plan? Some details we have written on this. It is defined as the schedule for the conducting the experiment. Okay. So selection of an appropriate plan is the primary tool for assuring the attainment of the objectives of the experiment. Is it okay? So you must have an appropriate plan. If the plan is say inappropriate, that means you may get the results from the experimentation, but these results are not reliable. The test plan identifies the factor combinations and factor levels to be included in the study. So if you have an appropriate test plan, how do you gain? In several ways. An acceptable or high degree of belief for the results obtained from the study. That means results are very reliable. Accurate estimation of important effects. Analysis of data from the study is simplified, and costs incurred and other resources required to conduct the experiments are most likely in control. That means if the experimental the test plan is appropriate, it might mean that that the cost incurred for doing the experiment may be at the minimum level. There are many types of experimental plans, right? So we have already we will be discussing those experimental methods. So each method when you try to follow, you must have a separate experimental plan. That means experimental plan may vary from one particular method to another. There are 2 types of the designs we will be referring to. One is a nested or hierarchical design. That means the levels of different factors are studied within a given level of another factor. Is it okay? That's why it is referred to as the hierarchical design. In the fractional factorial design and the unbalanced or partially balanced nested design. So just right at this point in time, we have not yet discussed the details of the nested or hierarchical design. Just make a note. Later on, if the time permits, we will be referring to certain examples related to hierarchical design or the nested design. In the composite designs, combination of factorial and nested designs are used. Is it okay? So the factorial design we will be discussing in detail. So if you combine say the factorial design with the nested design, what you get you get a composite design. That means many a time, depending on what type of product you are dealing with, how complex the product design is. So you have to select that whether it is a case of hierarchical design or it is a case of say the composite design. Okay, so this point just to keep in mind, later on we may refer to these cases. What is the grouping method? The method of grouping is an important tool for addressing noise variables in an experiment. Is it okay? This is very important, in fact, like say the blocking principles we apply. Now there are two important decisions to make concerning noise variables. Is it okay? First one is how to control the noise variables. Like that, suppose the temperature is a noise variable, so how to control them? Okay, while you carry out a particular experiment, so you have to set the value of say the temperature at a particular level. So how do you do that? And how to use the noise variables to establish a wide range of conditions for the study to increase the degree of belief. That means here is an experiment I have conducted where I say that all sorts of possible the conditions I have explored. Okay, so I have considered. That means whenever you say all possible types of combinations, directly or indirectly, you are referring to consideration of many types of uncontrollable noise factors. Is it okay? So how to control the noise variables? There are three methods. What are those? Hold them constant in the study. If it is 35 degrees Celsius, so okay, let it remain at 35 degrees Celsius for all the treatment combinations. Measure them and adjust for their effects in data analysis. Is it okay? So that adjustment is also possible. Okay, if you have enough data. Use planned grouping to set up blocks. That means you say that okay, I have chosen three levels of say the ambient temperature, and these three are only 90% of the cases. These three are the only possibilities. So accordingly, I will do the experiments under three specific conditions of the ambient temperature. When planned grouping is used in developing the test plan, the design is called a block design. I have been mentioning. Now the blocking means just one liner you have written, that is the blocking means grouping of relatively homogeneous experimental conditions. Is it okay? With respect to one particular condition, and say all the the experimental units are at the same condition. It helps in reducing or eliminating the variability transmitted from nuisance variables, factors that may not be of any interest but that influence the experimental response, which you cannot avoid, it exists, and improving the precision with which factor comparisons can be made. So this is the basic the principles of blocking. Now there are several examples. So these are examples of common noise variables used to form blocks are the time of day, that is one example. Okay, and I have already pointed out the operator. Is it okay? If you change the operator, that means it's a different block. Machine, if you change the machine. Okay, shift. Okay, if you shift say the morning shift to the afternoon shift, that means the morning shift data can be considered as one set of block, and the afternoon shift data may be considered is another say another block. Batch of raw materials and the month. In studying the wear for cars during normal use, an individual car is a natural blocking variable. Is it okay? The amount and type of driving for different cars could vary considerably. Different brands or factor combinations of tires could be tested on any particular car to minimize the car-to-car variation when comparing the brands. Is it okay? So I am just discussing a particular the situation, and if the natural block size is 4, 4 different brands could be grouped on each car. In studying the wear of soles or shoes, a natural block size of 2 would corresponds to the 2 feet of each individual wearing the shoes. Okay, so this is these are the ways you apply the grouping principles. In an analytical study, planned grouping plays a very important role in establishing the degree of belief for the results of the study. Okay, so this you must keep in mind. So the blocking principle is to be used almost in all sorts of situations. Including different machines will add additional variation. This is just an example, but will also increase the degree of belief. Suppose you want to study say the performance of a particular CNC machine. So if you just restrict yourself to just one particular CNC machine, that means whatever the results you obtain, those results are valid, those results are applicable, okay, only for that particular machine. Now suppose you want to generalize, right, the machining centers are CNC type. So obviously what you need to do, that means you need to consider in your experimentation not only one brand but the several brand of the CNC machines. Okay, so by treating the machines as blocks, the experiment can include multiple machines to increase the degree of belief in the results through analysis of interactions between the machines and the factors in the study. Okay, so what is randomization? Randomization means a random determination of the allocation of the experimental material and the order in which the test runs are performed. I have already explained, in fact. So it helps in validating the assumptions. Okay, any experimentation you do, that means there is an assumption or a set of assumptions. So what we believe in, that if the principle of randomization is followed, that means it helps in validating these assumptions. Randomization is the use of random numbers to determine the assignment of factor combinations to experimental units. So the selection of the factor combinations in a particular experimental unit is based on say randomization principle. Okay, so in most situations it is not desirable to complete randomization or to complete randomize the conduct of an experiment. It may not be feasible at all. So here is one example. So you please go through this particular example. Okay, it's not that say 100% the randomization is possible or feasible in a given situation. Now, decision of what type of level of randomization to use should be based on the objective of the experiment. Is it okay? So this is the point to be noted, and in the following situations, 3-4 situations I will explain where randomization is especially important. So what are those? Important response variables are not into a state of statistical control. Okay, so that is point number 1. Point number 2 is experiments need to be conducted by many different operators and on different resources and machines. So that is point number 2. The variation due to nuisance variables is large relative to the magnitude of effects of the important factors. Is it okay? So here obviously you need to consider the randomization principles. Now replication already you have defined. That means it refers to repeating particular aspects of an experiment. Replication plays an important role in attaining many of the properties of a good experiment. So everywhere, almost in all cases, we go for say replication, and it is a primary tool for studying stability of effects and for increasing the degree of belief in the results. So there are many different types of replication. Some of them are like this, like repeated measurements of the experimental units. Is it okay? Like we do when we to study the measurement error. Multiple experimental units for each combination of factors. So, this we have already mentioned. Partial replication of the experimental pattern, partial replication, and complete replication of the experimental pattern. Okay. So, these are the cases where the different types of replications you may opt for. The most important consideration in an experiment is not the number of experimental units per level of a factor, but the breadth of conditions under which the comparisons can be made. Replication over similar conditions provides little increase in the degree of belief. Okay, so, you need to change the condition in many a time. For example, in a high speed manufacturing operation, a study based on 5 to 10 experimental units selected from different days production and made from different material lots would be much preferred to a study based on 50 consecutive produced units. Is it okay? So, I think the point is made very clear. Okay. So, replication is an important principle. Now, what are the experimental design methods? There are many, as I have been telling you, and an experiment is a planned method of inquiry conducted to support or refute a hypothesized belief. That means, whenever you carry out an experiment, what is your background knowledge? The background knowledge is the inferential statistics. That means, the hypothesis testing, you must have the thorough knowledge in hypothesis testing. So, through an experiment, what do? You try to discover new information about a product or the process or the service. So, that is why during the product development stage, particularly at the prototyping stage, use of experimentation is very common. Is it okay? Now, these the factors which you have mentioned, like these are also referred to as the parameters, and sometimes these factors are also referred to as the input variables. So, examples of parameters, like say in order for for making the process in the control level or controlled, what you try to do, you apply the control charts. That means, make sure that the process is in statistical control, and for that one exercise you carry out, that is the process settings, and we refer to the process parameters. So, what are those examples of the process parameters? So, like say the type of material, the spindle speed of a machine, the temperature setting of a furnace, type of coolant used, and the supplier selected for a process. So, there are many examples. For quantitative factors, the range of values, how they are to be measured. Okay, like say if you say the spindle speed 500 rpm, how do you measure it? Then the levels at which they are to be controlled, that means whether you should control at 500 rpm or 450 or 650. So, this should be specified, and then only you can do experiments for at different levels of a factor. So, this is just I will read this example. The effect of temperature on the output of a product may be required to be studied through experimentation. 3 selected levels of the factor may be 100, that means the temperature is the factor, okay, and you have 3 levels 100, 200 and 3000 degrees Celsius, 300 degrees Celsius, and the raw material can be purchased from vendor A or vendor B. The treatments for this experiment are the various combinations of these 2 factor levels. The vendor A with 1000 degrees Celsius, this is 1000, 2000 and 3000 degrees Celsius. So, the vendor A with 1000 degrees Celsius over oven temperature is one treatment. A total of 6 possible treatments can be considered in this case. That means obviously three levels you have, and you have 2 vendors. Is it okay? So, there must be 6 combinations. While conducting an experiment, the effect of a response on a response variable for a chosen treatment combination is measured. If this effect is measured for the whole batch of production, the experimental unit becomes the population. Is it okay? That means you have considered all sorts of combinations. In most cases, consideration of the whole unit may not be necessary. Is it okay? Sometimes the results are repetitive. So, when you study a particular system, what they say that the study for the entire population may not be necessary. So, in this case, a sampling unit you select, and what is a sampling unit? A sampling unit is a fraction of the experimental unit on which the treatment effect is measured. It's clear? So, the variation in experimental units that have been exposed to the same treatment is attributed to an experimental error. That means, same treatment the combination you have considered, and you go for replication. What you get that the same the value in a particular response variable you may not get. Is it okay? So, this is may be referred to as the experimental error. So, you have come across this particular term called experimental error. So, in any experiment you conduct, you must know that what is the level of the experimental error, whether this experimental error is significant or not. Is it okay? So, this variability is due to uncontrollable noise factors. If you conclude like this, you say yes, error is acceptable, but if you cannot conclude like this, that means you have to improve the design methods. Okay. So, in majority of the cases, more than one factor is considered in experimental analysis. In such cases, experiments do not usually involve changing one variable at a time. With two variables, the experimental design is presented. One figure is there. So, what you do, each factor can be set at two levels denoted by -1 and +1. The point 0,0 may represent the current setting of the factor levels. So, in this figure, the first coordinate represents the level of factor A and the second coordinate the level of factor B. I will show you the figure immediately. First, you go through all these details. A level of -1 represents the value below the current setting of 0, and a level of +1 represents a value above the current setting. This is just an example. Thus, for 4 new design points -1, -1, +1, -1, -1, +1 and +1, +1. So, these are the possible combinations you have. So, for each combination you have to carry out an experiment. The value of the response variable at these design points represents the results of the experiments performed. Okay. So, the response function value at the experimental design points is shown in the next figure, and the response surface shown in this. The objective is to maximize or minimize the response function. That is most important. That means, how do you measure say the performance of the product? Obviously, it is represented by the response function. So, you must be able to create this response function. Accordingly, the direction at which the gradient is steepest is to be considered. Okay. So, this is one case. That means, this is the present level. So, these are the two factors you have considered, factor A and factor B. So, these are the 4 combinations you have, and against each combination what is the response value? Is it okay? Like 70, 75, say 100, 85. Then what do? You consider the factor A and the factor B with respect to factor B, response surface for the two factors you consider. So, this is the response surface. Okay. So, there is a methodology called response surface methodology. Normally, once the experimentation is over, the next topic we discuss, that is the response surface methodology. The students who are interested in studying the response surface methodology, any textbooks on statistical design of experiments, you will find there are few chapters. There is one chapter towards the end that deals with this response surface methodology. So, please refer to this one. Is it okay? So, now we have we have just discussed the basics and how the responses are related to means if you have so many kinds of responses, suppose you have through experimentation, so you have come to know. So obviously you can define the response surface. Is it okay? So this is the basic experimental design methods. And then what you try to do, these are the experimental points we have and the response function value at the design points. Is it okay? So this is another way you can represent it. Already we have pointed out this one. Okay. So what you try to do, that means design approach involving changes in one variable at a time. Is it okay? So one variable at a time, the results are not that conclusive and not that reliable. So this figure shows the response function value at the design points. To maximize the response function in this experiment, the direction of arrow shown should move along the major axis of the factor A. That means this is if you want to improve the performance, what you try to do, that means the factor A value should be around, say, increasing value. That means from this direction you have to move. Is it okay? So this way you can interpret, and this is the another dimensions you have added, the treatment combinations with 3 factors. Previously we consider 2 factors. Now you have added the third factor, that is factor C. So factor A, factor B, factor C. So how many combinations you have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 combinations we have. So there are 9 treatment combinations with factors A, B and C. Is it okay? So here plus 1 combination is here 0. Okay. So when 3 variables need to be considered, the same approach as outlined for 2 variables may apply. Okay. So there are 9 treatment combinations, and to obtain the same amount of information given this design, using 1 variable at a time approach, 4 sets of experiments each with 7 design points need to be done. Okay. So this is the way you define the treatment conditions. When this is the low level, minus means low and plus means high level. Is it okay? You may have a specific values. So when the relationship between the response variable and certain factor is influenced by the levels of some other factors, there exists an interaction effect. This concept is illustrated graphically in figure. So here this is the way, that means here the interaction between factors, how do you come to know? That means here this is the minus level, plus level. Factor B is at the low level, factor B at the high level. So what do you find? That is this 50, this becomes 70, this becomes 100, this is 120. That means the difference is just 20 units. So you may conclude that there is no interaction effect. Whereas here what you find, that you consider between factor A and factor B. So the factor A is at the low level as well as the high level. When it is at the low level, okay, so then you consider this value, that is the 50 for factor B, that is the low level, and factor B is the high level. Now at these conditions what you find, this is 50 and this is 80. Here at the high level of A, and what you find, this is at 70, this is at 130. That means here the difference is 50, here the difference is 20. Is it okay? So what you conclude, that there is an interaction between factors A and B. That means while you explain the response variable, you should consider not only the main effect, that is factor A as well as the factor B, we also must consider the interaction effect given by A into B. Is it okay? So such the plotting will help you in understand that whether between the factors there is an interaction or there is no interaction. Okay. So the other details we will go through, in fact, like the contour plots and all those. So please go through them. This is a contour plot, that means no interaction between factors A and B. So this is at the same level you have. Whereas if you have this sort of contour plot, is it okay? Immediately you conclude that there is an interaction effect. That means factor A is influencing factor B, and this influence is affecting the final outcome that is given by the contour. Is it okay? So I conclude it here, and we'll move to the third topic in our next lecture session.